Okay, sure. Multiple choice questions. First question. क्या है first question? Two particles A, B proceed simultaneously in the direction shown in the figure with velocities VA, VB, D हुई है. So they collide in the air after 1/2 seconds. Then अच्छा, so half second के बाद में collide कर जाएंगे. With respect to VB क्या हो रहा है? Just like okay, wait, this is theta you are saying, huh? Weird. So like okay, understood. So first of all, कि y versus similarity like यहाँ पे 10 है, which means right. Theta is just 30 degree. So angle theta is 30 degree, which is C is correct. Or kya? So that's 30 degrees. Like this is going to be 20 square root of 3 in that case. Wait, no, 10 square root of 3, of course. Okay, so that's 10 square root of 3. So, and they collide in half seconds. Okay, so 10 square root of 3 times half, which is just 5 square root of 3 is x. So x is 5 square root of 3. मतलब कि B is correct and C is correct. That was, ये तो मुझे लिखने की जरूरत भी नहीं पड़ी, तो काफी easy था. Second question. Okay, a uniform square plate of mass m h A initially at rest starts rotating out one of the edge under the action of constant tau. Then the okay then wait क्या है mass m h a fine right. Then at the end of the fifth second after start, end of fifth second. So first second is like from 0 to 1, right? Okay, so basically at t equal to 5 seconds, of course. So at t equal to 5 seconds क्या चाहिए अपने को? Angular momentum and whatnot, right? So just tau constant. Yeah, so a is correct. Kinetic energy is equal to it's like half inertia omega square or something like that, right? It's like half inertia omega is just tau and wait what? Nahin, tau times time. Sorry. So like yeah, because tau is like dl upon it. It's like you get the thing, and that times of omega once again. But omega is what? Omega is once again just no like it's l upon m. Yes, like half I omega square is like the same thing as half l squared upon m. It seems half l squared upon l squared upon I. Okay. राइट तो एल कितना है 25 tau squared upon 2 inertia. So inertia about that edge is just ml squared about like ma squared upon 3. Okay, so just what 3 ऊपर जाएगा, it's just 2 ma squared it seems. 75 upon 2 tau squared about yeah, so that's going to be d in this case. Next question. So d is correct and a is also correct, right? Okay, so ad. Third is a particle of mass m velocity v naught is fired in a solid at a solid cylinder of mass m radius r. The cylinder is initially at rest and is mounted on a fixed horizontal axle that runs through the center of the mass. Okay. The line of motion of particles perpendicular to the axle. Okay. Distance d less than r from the center and the okay समझा. So this is like so ये तुम्हारी डिस्क है सॉलिड सिलेंडर फर्स्ट ऑफ ऑल. ओके, दिस तुम्हारी एक्सल, ये जो डिस्टेंस है. सो राइट, व्हाट वाज द थिंग वंस अगेन? the line of motion of particles perpendicular to the axle at a distance d less than r, so ये d है, from the center and the particle strikes at the surface of cylinder. Then okay, तो like angular momentum कंजर्व होगा. that's the thing, because ये जो भी forces है ये torque नहीं create कर सकते. Yeah, and what else do you want? Energy change हो सकती है, right? Because so it sticks to the surface, right? Yeah, right. Angular momentum of the system just after the particle sticks is this thing. Well, no, it's the same thing as m v naught d. v naught से तुमने this किया, right? So okay, wait, angular speed, not angular momentum. Then fine, it's just m v naught d upon the new inertia, which is just r squared times. Wait, oh yeah, just mr squared upon 2 चाहिए ना इसमें. Fine, let's find this thing. Flow 2 ऊपर जाएगा, so actually this thing. A looks correct. और क्या mechanical energy is conserved? No. I think D is correct. Mechanical energy is not conserved because half I omega squared. Singular अपने को omega मिल गया, just half I omega squared. That's not good. Actually, you just do L squared upon 2I, right? Well, yeah, L squared is like what? M squared, V naught squared, D squared upon 2 times this inertia is like कितना mr squared upon 2 plus mr squared. So basically r squared times हाँ ठीक है, just m plus 2m in that case, right? Well, yeah, I guess that's the thing. So just r squared times m plus 2m. Right. This is our energy. This is equal to initial energy. Is that the thing? Wait, नहीं, देखो equal होना चाहिए. We just want this energy subtracted from the initial energy, right? So अपने पास ये प्रूफ करना कि ये equal नहीं है. So basically, is this equal to half mv naught squared? Right? That's what we are asking. So ये तो गया, ये क्वेश्चन नहीं गया because यहाँ पे कुछ भी नहीं है. राइट, तो m एक जाएगा v नॉट स्क्वायर जाएगा. It's like asking is md square is equal to, okay, this 2md square equal to r square times. So for some certain value of d ऐसा हो सकता है शायद से. Oh god. Okay. So mechanical energy may or may not be conserved. We don't know for sure. Wait, okay, wait. I think I got it. So just d is equal to what? R square root of m plus 2m. तो अगर कंजर्व होनी चाहिए then this is the thing, m plus 2m upon 2m, but guess what, this thing is bigger than 1 and we know that d is less than r, तो ये तो मतलब नहीं बनता ऐसा कुछ. So yes, it's not conserved. So d is the answer. Next question. So a है और d है, right? Fourth is a simple harmonic wave is traveling along a straight line. The distance between the 2 points in the same phase is 5 meters. What simple harmonic wave traveling along straight line, distance between 2 points in same phase is 5 meters. Like lambda is 5 meters basically. While the distance between the 2 points in opposite phase is 1.5. So, God, wait, what? No straight line. Okay. 2 points in the same phase is 5 meters. Okay, it's not just fine. It's like 5 is equal to lambda n, and 1.5 is equal to lambda upon 2 plus lambda n, or like lambda m or whatever. मतलब कि 3 is equal to lambda plus 2 lambda n, if that makes sense. Okay, so ये x मैच चाहिए, right? Yeah. And just divide this, like 5 upon 3 is equal to n upon 2m plus 1, right? Okay, so like 10m plus 5 is equal to 3n is our equation. Another diopentane. I don't like this actually. 10m minus 3n. Oh god, what the down wala nahi. So 5 is equal to what? 3n minus 10m. कोई एक nm की solution pair ढूंढ लो, which is just 5,1 I think. So yeah. और फिर क्या? So इसका GCD क्या है? यहाँ पे तो 10 आ गया. Oh shit, ये 5 आ रहा है. Then n is necessarily a multiple of 5 all the time. Okay, so n is necessarily a multiple of 5. Let's say n equal to 5k, then 2m plus 1 has to be 3k, right? But yeah, you can just put n equal to 5k where k is an integer, and 2m plus 1 is equal to 3k where once again k is an integer. And of course, like k is odd, so like basically n is 5 times an odd. Oh god, ये क्या हो रहा है? It's an odd integer. So like 1 is equal to an odd integer times. God, what is this? Okay, what can be the wavelength of the wave? 1 upon an odd integer. So 0.5 नहीं. 1 upon 3 maybe. 1 upon 7 शायद उसमें. This is weird. Or क्या 2m plus 1 equal to 3k where k is an odd integer for sure. Okay, and that guarantees that this can happen, right? Yeah, because 2m plus 1 is equal to, right, वो हो जाएगा. This equation just becomes what, like 3 equal to 3k, like k lambda, of course, like k lambda equal to 1 from both equations, and k is an odd, right? So I think C and D are possibilities, right? So C and D. इसलिए बार check कर लेते हैं. So if wavelength is 1/3, तो 5 is like 15 lambda, isn't that right? So yeah, that explains it. And 1.5, this is like 3 upon 2, which is, so 3 lambda times, so like, okay, 9 upon 1, right? That's what this will be. Yeah, 5. 3 upon 2 is 9 upon 2, that's 1 upon 6. 3 upon 2 lambda, 9 upon 2 lambda, which is, yes, it's just half plus something integer, so that works out. Or 1 upon 7, yes, 21 upon 2, that also works out. So ठीक है, नहीं दोनों काम करते हैं. Fifth question. Okay, for the system shown in the figure, all pulleys are light and frictionless, and springs are ideal. Initial system is held at rest by some external means. Now the system is released, i.e. external effect has been removed, but still it has been displayed. What observed that 10 kg and 5 kg blocks are not moving? This is possible when? So क्या 10 kg and 5 kg blocks are not moving? Oh, तो ये मूव नहीं कर रहा, मतलब कि ये वाला मूव नहीं कर रहा, मतलब कि ये भी मूव नहीं कर रहा है. That's weird. तो इस पे जो force लग रहा है like this is 5 kg holding this up, right? Okay, got it. So half of that's like 20. Okay, cool. So 5 upon 2 in this direction, right? Yes. और वो g को मैं like okay 5 upon 2 g basically acceleration in that direction because of this guy. क्या बोल रहा हूँ आखिर? 5 upon 2 g force, right? Yes. So what was the thing once again? Yeah, what was the thing? String constraint, right? That's our equations. Like 5 upon 2g, that's this force in this direction. Okay. God. Then फिर plus tension, because there's also the tension. Like this is the tension, of course. Right. Then this minus g. So m1g, right? Okay, this thing upon m1 in that case. Like t is equal to 5.2g. That's what we're basically saying. इस चीज के लिए ऐसा हो रहा है. And now just apply this thing कि right. So string constant apply करोगे. It's like g minus t upon m1 plus g minus t upon m2 equal to 0. It's like 2g is equal to t times of 1 upon m1 plus 1 upon m2. And then now we know कि t क्या है? Just 5 upon 2g. इसका मतलब क्या हुआ कि 4 upon 5 is equal to 1 upon m1 plus 1 upon m2. So m1 and m2 can have many possible values. Yes. Sum of m1 and m2 is 5 kg. Harmonic mean of, right, that's 5 upon 2 for sure. So D is the answer. Next question. Okay, next. Sixth. Current in R3 is, okay, in the shown circuit. R3 कहाँ पर है? ये चीज. So यहाँ पे E है. अच्छा, just after closing the switch. Just after closing the switch क्या हो रहा है यहाँ पे? इंडक्टर पे कुछ भी नहीं फ्लो हो रहा है, तो वो तो बस हटा दो. कैपेसिटर बेसिकली बिकम्स लाइक अ वायर. तो यहाँ का पोटेंशियल और यहाँ का पोटेंशियल सेम हो गया. Oh God. और ये जो पूरी चीज है, दिस इज लाइक नॉट करेक्ट कैरिंग एनी करंट, तो वो उसको हटा दिया अपने. इट्स जस्ट राइट. सो R3 और R2 दोनों फिर जीरो करंट हो गया, राइट? जस्ट आफ्टर क्लोजिंग द स्विच करंट इज जस्ट जीरो. यस. ओके, नॉट दिस थिंग. लॉन्ग आफ्टर क्लोजिंग द स्विच, राइट? ओके, तो कैपेसिटर इज लाइक नाउ नॉट कैरिंग एनीथिंग. ये वायर हो चुका है. तो या इट्स जस्ट दिस थिंग. It's E upon R1 plus R2, it seems. Yes, so E upon R1 plus R2, which is still not there for some reason. Okay, wait, R3 में चाहिए. For sure. Okay, wait, क्या था? इससे गड़बड़ हो रही है. He's carrying all the current in that case, right? That's him like a wire. और यहाँ से कोई भी current pass नहीं हो रहा because, well, yeah, just after closing the switch, zero है, and long after closing the switch, inductor is carrying all the current because like yeah, this is not carrying any current. ये voltage same हो गए. Once again no current through it, so still it's zero. So A is correct and B is correct. Seventh is capacitor C1 of a capacitance 1 microfarad and capacitance C2 of 2 microfarad separately charged fully by common battery. The two capacitors are then separately allowed to discharge through equal resistors at time t equal to 0. The current in each of the two. अच्छा, basically CR circuit का क्या होता है? Basically like what is this thing? Q upon C is equal to RI, or yeah, and then I is just negative dq upon dt. And अपने को क्या क्या पूछा है करंट के बारे में, and also charge बारे में पूछ ही रहे in the end. We'll just figure out about charge itself. Like Q is equal to negative, or I should probably say this thing that dq upon dt is equal to negative 1 upon RC times Q, right? So yeah, first order kinetics, which means your Q is of this form. It's like Q naught, जो भी होगा इसमें we don't know. Then e power negative kT is like T upon RC, right? Yeah, that's the thing. So for both of these cases, और resistance का क्या है? Equal resistors, cool. So right, the current in each of the two discharging circuits is zero. At t equal to 0 क्या हो रहा है, right? At t equal to 0, wait, what? No, it's not 0. It's not. Current in the two discharging circuits are equal but not, God, no. एक में, wait, actually नहीं. V is the same thing for both of these guys. So ठीक है, these are in fact equal but not 0. Yes, so B is correct. Currents in the two discharging circuits equal to 0 are unequal. No. Capacitor C1 loses 50% of its initial charge sooner than. Okay, तो half life is like R C नहीं है. It's like natural log वगैरह आने वाला है जो भी है. For that to be half, you just want natural log 2 is equal to negative. Okay, just T upon RC. So like T half is RC natural log of 2. So जिसका कैपेसिटेंस बढ़ा उसकी हाफ लाइफ बढ़ी. कैपेसिटेंस C2 का जो है that is 2 microfarad. So sooner than. Yes, I believe that was C2 का. Right. So C2 का half life like 2 होगी तो C1 की 1 होगी. Right. Right. So D is correct and B is correct. Next question. It is in which of the following cases is the power being delivered by a given progressive sinusoidal wave on the string doubled? The wave amplitude is doubled, giving frequency the same. The wave frequency is अच्छा अपने को बस करना पड़ेगा, right? So you want the power. Okay, cool. It's just what T. I don't like this, but whatever. Just T partial y upon partial x and then partial y upon partial t. I guess that was the thing, like velocity and then the force, right? So क्या ना like t a squared and I think तुम्हें एवरेज पावर चाहिए बस फेज के बारे में कुछ बोल नहीं रहे लोग. सो ठीक है फिर. एंड देन यहाँ से क्या आएगा, इसमें आएगा k, इसमें आएगा ओमेगा, दोनों में a आने वाला है एंड देन वो जो साइनसॉइडल फंक्शन रहेगा लाइक हाफ. दिस इज अवर पावर आई थिंक जो भी है. राइट. Okay, so the wave amplitude is doubled, giving the frequency. It's like proportional to what? Proportional to a squared tension, the frequency, and upon the wavelength, right? Yes. Okay. और अपने को पता है that t is basically equal to lambda c squared, right? Okay, जो भी है. Okay, so lambda. Okay, it's not lambda. I should probably say mu times c squared. जहाँ पे mu linear density है. So तुम टेंशन के बारे में कुछ बोल रहे हो क्या? String is double, keeping the tension same. Diameter of string is double. That's like linear density is made. Wait, but material तुम्हारा change हुआ क्या? नहीं, I don't think so. Wait, okay, तुम्हारा नहीं हुआ change, but तुम्हारी linear density तो still change होगी ना? Yes, because अब उसी cross section पे 4 times. तो yeah, now it's like 4 times. So in किस केस में double हो रहा है? क्या? ओके क्या डबल हो रहा है? पावर. ओके कूल. सो पहला है वेव एम्पलीट्यूड इज डबल्ड. सो एम्पलीट्यूड को डबल कर दिया देन इट्स लाइक 4 टाइम्स. नॉट करेक्ट. वेव फ्रीक्वेंसी इज कट इन हाफ. आई डोंट थिंक दैट्स कीपिंग एम्पलीट्यूड सेम. ये हाफ कर दी तुमने बट देन और क्या चेंज हुआ? टेंशन को तुमने चेंज किया क्या? आई डोंट थिंक सो. well if that's the case then lambda जो है like f square upon c हो जाएगा. so c will be the same which means कि समझा, right? that will just mean कि वो 4 times like 1/4 times हो जाएगा, right? Yeah. Yes. The string is made 4 times as taut, keeping its linear density the same. तो मैं जो C है ओके ओके सो T जो है वो 4 times हो गया एंड इट्स लाइक वेट बट मैं फ्रीक्वेंसी और लैम्डा के बारे में कुछ बोला नहीं. व्हाट अबाउट द फ्रीक्वेंसी? व्हाट अबाउट द वेवलेंथ? क्या तुम वो चेंज नहीं कर रहे हो? वेट बट दे आर डिपेंडेंट ऑन C बेसिकली. God, no. But we don't know. तुमने वेवलेंथ को चेंज किया कि क्या तुम सेम रख रहे हो? Your density is same, but we don't know whether it's like wavelength. Ah, I think कहीं यहाँ पे wavelength है नहीं, so you have to get rid of the wavelength somehow. So इसको just c upon f कर डालो, so just get this thing f squared upon c in that case. So string को तुमने 4 times start कर डाला, then तुम्हारा जो c right becoming what like mu times of c square. So basically like what? This thing, right? Right? बड़ा लंबा था ये तो. ठीक है तो तुमने म्यू चेंज नहीं किया, तुमने स्ट्रिंग को तुम्हें 4 टाइम्स से स्टार्ट कर दिया, तभी तुमने सी को ट्वाइस कर दिया. सो यस सी विल बी द करेक्ट ऑप्शन. तब वो डबल हो रहा है अज्यूमिंग तुम्हारी फ्रीक्वेंसी में चेंज नहीं की. डायमीटर ऑफ द स्ट्रिंग इज डबल. तुमने म्यू को कर दिया है 4 टाइम्स, राइट? राइट. mu को and keeping the tension the same, हमारी जो C चीज है, oh god, हमारा tension तुमने same रखा है, okay, that I have to get rid of like C somehow. जैसे इसको square root of T upon mu का डालो, basically क्या बचता है, square root of T times mu. So yes, mu तुमने 4 times कर दिया, like still double हो गया. So D is correct. Next question, 9th. Which of the following statements is or not false? The magnetic force does zero work on a charged particle moving in magnetic field. Yes, that's right. Dry-charged particles, sorry, charged pieces of paper are attracted to a stationary magnet. No, नहीं, ऐसा कभी नहीं होता है. They have to be moving or something. Dry-charged pieces of paper experience force in the presence of a moving magnet. I think yes. Okay. The magnetic, so C looks correct. Wait, I'm ये कौन से false है? So B is definitely just false. A is true. So B is false. Or क्या magnetic torque on current carrying coil of wire has its maximum magnitude when the magnetic field is perpendicular to the plane of coil. Magnetic torque on a current carrying coil. Okay, got it. When the magnetic field is perpendicular to the coil. नहीं, because in that case magnetic momentum ये तो same हो गया. Like torque zero हो गया in that case. That's not the thing. So D is wrong, which means like D is a correct option and B is the correct option, right? So B and D. Next question. 10th. For two different gases XY having degrees of freedom F1, F2, molar capacities, molar heat capacities, C1, CV2, okay. Right. And natural log of fields, natural log of V graph is plotted for adiabatic process as shown. So what do you know, like natural log of P plus gamma natural log of V is equal to a constant. So just slope rahega, it's just negative gamma, I think, right? Slope is just negative gamma. Or for what are you doing this? Okay. अच्छा तो ये दिस इज व्हाट 2 किसके लिए है, y के लिए, देन 1 है फॉर x. स्लोप किसका बड़ा दिख रहा है तुम्हें? समझ तो मुझे कुछ नहीं आ रहा है इसमें. बट इट सीम्स कि x का जो स्लोप है इट्स बिगर देन मैग्नीट्यूड, व्हिच मींस दैट x का गामा लाइक गामा x इज बिगर देन गामा y. गामा होता क्या है, जस्ट इट्स लाइक 1 अपॉन गामा x इज बिगर देन 1 अपॉन गामा y. एक्चुअली गड़बड़ कर रहा हूँ ना. या ओके इट्स लाइक cp अपॉन c चाहिए, तो 1 अपन की जरूरत है नहीं. इसीलिए लाइक व्हाट gamma is like 1 plus 2 upon x, तो जिसका डिग्री ऑफ फ्रीडम बड़ी है वो छोटा, right? It's like fx is less than fy and cbx is less than cdy, not f1 less than f2. So B is correct and C looks correct. B and C. Next question. 108, sorry 108 क्या है ये, 11 क्या कुछ भी बोल रहा हूँ मैं. Okay, the two blocks AB of equal mass are initially in contact with when released from rest on an inclined plane. The question of friction between the inclined plane and A and B are mu1, mu2. Okay. If mu1 bigger than mu2, it's like mu1 g sine theta is that right retardation or whatever. Okay. So if mu1 is bigger than mu2, the blocks will always remain in contact. I believe so. Yes. mu1 less than mu2, the free A सामने move करेगा. Blocks will slide down with different accelerations. Yes. So B is also correct. A is correct. B is correct. If mu1 is bigger than mu2, the blocks will experience a common acceleration of this thing, half mu1 plus mu2 g sine theta. What? No. Wait, what? That doesn't actually make any sense. Wait. नहीं यार, it depends on the mass as well, I think. अच्छा, equal mass. Okay, that does it. So like g sine theta minus the average, right? Okay, but nahi, that's not their acceleration. Actually, it's like you don't want this to be the thing. यहाँ पे 1 minus mu1 and 1 minus mu2 चाहिए था, in fact. So like, no, C does not look correct to me. Okay, और क्या है, mu1 less than mu2, कॉमन एक्सेस तो रहेगी नहीं अगर that happens. So A and B are only correct. 12th. This is like retardation due to friction, but that's not their acceleration because g sine theta तो act करने वाला है, right? Yeah. जो भी है, next question. Yeah. Next, a ball of mass m is attached to the lower end of a light vertical spring of force constant k. Okay, the upper end is fixed. Okay, the ball is released from rest with spring at its normal unstretched length and comes to rest again after descending through a distance x. Kitna x? Acha, okay. I mean, that's pretty easy. Like mgx is just equal to half kx squared. Is that really a challenge? No. X is just equal to what? 2 mg upon k. That was not that bad. So B is the answer. Or we know that that's one of the extreme positions. So actually, mg upon k is the equivalent position. जो भी है. Or क्या the ball will have no acceleration at the position when it is what x upon 2. Yes, right. The ball will have an acceleration equal to g at its lowermost point. ओके सबसे ऊपर क्या है डाउनवर्ड एक्सेलरेशन जी है यहाँ पे ऊपर रहेगा वो एक्सेलरेशन या सो सी इज करेक्ट एंड डी इज करेक्ट नेक्स्ट 13 a body moves on a horizontal circular road of its r with tangential acceleration a. Okay, the coefficient of friction between the body and the rod sorry on the road surface is mu. Okay, the road of radius r tangential acceleration fine. It begins to slip when its speed is v. अच्छा तो कब स्लिप करना शुरू होगा राइट वेल ओके सो v स्क्वायर अपॉन r इज इक्वल टू डेरिवेटिव ऑफ फोर्स ऑफ कोर्स एंड या वो जो बॉडी है द ओनली फोर्स ऑन इट्स लाइक द फ्रिक्शन फोर्स एंड नॉर्मल फोर्सेस है वो इग्नोर करो यार ओके सो नॉर्मल फोर्स इज जस्ट इक्वल टू mg जो भी है ओके so mv square upon r is that's this force. This is also the friction force itself. This is actually less than or equal to, so mv square upon r is less than or equal to mu times, I believe that is the thing, just mu times of right, what else could be the thing, right? Just mu times of mg in that case. कुछ और ऐसा है, is this like इसका r change हो रहा है क्या? नहीं, then there's no problem with that, right? R double dot is like 0 in that case. So yes, it's any bit of acceleration or the radial component of acceleration vector. That is just mv square upon r in that case. Okay, force vector, जो भी है. नहीं, that's not the thing. Look, it's not just this. Friction और भी एक चीज का जैसे right. Tangential acceleration as well. You have to count that. Yes, you have to count that. So actually क्या रहने का पूरी एक्सेलरेशन कितनी है? पूरी एक्सेलरेशन लाइक स्क्वायर रूट ऑफ v पावर 4 अपॉन r स्क्वायर्ड प्लस कहाँ पे मर गया वो व्हाट वाज दैट थिंग क्या है एंगुलर एक्सेलरेशन टेंजेंशियल एक्सेलरेशन a1 a1 का स्क्वायर राइट या that's the complete acceleration vector which is provided only because of the frictions like m times of that. This is the friction force less than or equal to mu mg. तो मतलब क्या हुआ इसका that this is the thing. Okay, so like v power 4 upon r squared is less than or equal to mu squared g squared minus a1 squared. So right, when speed is v तो v power well yeah, so v power 4 plus okay, ये चीज a t था मुझे अभी तक a1 दिख रहा है. So c looks correct. The force of friction makes an angle through with the direction of motion at the point of slipping. So at the point of slipping, sorry, ow. Okay, at the point of slipping, क्या हो रहा है? In fact, tan inverse. Okay, that's weird. Oh, okay, yeah, that is the thing. So we sort of that doesn't matter. ये तो कभी भी होगा ना. Not just at point of slipping. कभी भी जब ये ऐसा कर रहा है, then it's like this thing. So that's with the direction of motion, of course. So यहाँ पे है at along direction of motion, and then you have this v square upon r along that. So yes, this is the thing that you want. Like, yeah. So v square upon r upon at, right? Which means C, D is correct. Next question. 14. The density of a rod AB increases linearly from A to B. Its midpoint is O, and its center of mass is at C. 4 axes pass through AB and O and C, all perpendicular to the length of the rod. Density of the rod AB from A to B. Midpoint is at O. Center of mass is at C. Okay. Moment of inertia of the rod about राइट ओके। और जो एंड्स है, वेट व्हाट, राइट, A to B increase हो रहा है, राइट? So this is A, this thing is B, O is over here, and then center of mass is over there, right? Okay. Just figure out कि center of mass कहाँ पर है पहले तो. It's like what integration of, हम बस ऐसे ही बस figure out the number that you want to put. Just क्या है, linearly increasing x and then dx, that's like depending on mass, ये mass से proportional रहने वाला है. And then this times of x once again because of the position भी उसमें डालनी है, so just x square dx then upon integration of x dx, right, from 0 to I don't know, just L, 0 to L जो भी है. Yeah, that looks correct. वो लैम्डा मर जाएगा वो अपने आप में, like x cube upon 3 is L cube upon 3 upon L squared upon 3 it seems. So L shit ये 3 नहीं 2 है, sorry, this 2/3 L it seems. So यहाँ पे 1/3 L distance है and this is L upon 2, so ये distance कितना होगा, L upon 6. Okay, cool. So from C कितना distance है इसमें, this thing is L upon 3, this is like 2L upon 3. ये जो पूरी चीज़ है, this is like 2L upon 3, okay, and this is L upon 6. So अपने को जो inertia चाहिए at C equals something, IO, right, पहले आएगा, फिर IB आएगा, फिर IA. So IA bigger than IB, bigger than IO, bigger than IC. So IA bigger than IB, yes. अपने चाहिए करेक्ट है ना, ओके. IA less than IB, नहीं. I क्या है ये चीज़, O bigger than IC, no. IO less than IC, yes. So D is correct and A is correct. Yeah, next question. Wait, C, shit, ये C की बात कर रहे हैं, okay, B की बात नहीं कर रहे हैं, कुछ अलग ही कर रहा हूँ. So of course IO is bigger than IC, so C is the answer. Okay. And IA is bigger than IB, I believe in that, yes. Okay, next question, 15. A square plate lies in the xy plane at the center at the origin and edges parallel to x and y axis. Square plate xy plane में centered at origin, edges parallel to the x and y axis. Okay, cool. Its moment of inertia about the x, y, and z axis are Ix. Okay. And about a diagonal it is Id. Okay. So about a diagonal we want. Fine. अब देखो ढूंढना क्या है? Right. Like Id is the same thing as Ix is equal to Iy. I know that. Ix equal to Iy is equal to Id. Right. And half Iz. Yes. So A is correct. And Iy is equal to 2 times. Nah. No. That's not right. Okay, ID equal to Ix, yes. C is also correct. ID equal to Iz, no. So C is correct and A is correct. बिना कैलकुलेट किए अपन डायरेक्टली बोल रहे हैं, which is not that hard to calculate because अपन Ix और Iy easily calculate कर सकते हैं. Four identical rods, each of mass m and length L, are joined to form a rigid square frame. Frame lies in the xy plane with the center at the origin, sides parallel to xy. Moment of inertia about the x-axis is what? For the y-axis, God. ढूंढा y-axis क्या होने वाला है? तो क्या है, 4 rods. Okay, mass m, length L, right? So yeah, ऐसे अपन 2 rods, एक ऐसा एक ऐसा यहाँ पर है. This is our x-axis. It's about this. ये rod का क्या रहेगा? Just like m L upon 2 square upon 3, right? So इसमें upon 3 तो आने वाला है 2 upon 3, like ml square आने वाला है इसमें. इसमें जो है, इसमें L upon 2 का स्क्वायर इसमें रहेगा, so like इसमें 1 upon 4 आ गया एक्स्ट्रा फैक्टर. Otherwise सब कुछ सेम है. And then oh shit, it's not the same. It's not the same. Oh god. ठीक है, like 2 times, do it correctly. ml squared upon 4 times 3, right? Which is 12, right? For this rod. और ये rod के लिए क्या? It's distance like L upon 2 just ml upon 2 का square, so like ml squared upon 4. So this is like what, ml squared upon 2 times 1 upon 3 plus 1, right? Which is 4 upon 3. So 2 ml square upon 3 पूरे सिस्टम का, ऑफ कोर्स ये 2 ऐसे नहीं डाला अपन ने, वो एक रीजन की वजह से. So this is Ix or Iy or whatever. Okay, करना क्या अपने को, आप मर गए. So about x-axis is this thing, yes. About the z-axis is 4/3 ml squared, yes, I believe in that. और क्या है, and x is parallel to the z-axis and passing through the corner. God, I don't like this. It's 10 upon 3 ml squared. ठीक है, like total mass कितना रहेगा इसका 4m. We'll have to do this. 4/3 ml squared plus, so what your distance था is like L upon 2, L upon 2, sort of L upon 2, L upon sort of 2. So L squared upon 2 times, that is the thing, right? Yes, and that is like 4m over there. Just ml squared times 2 in this case. So this plus 2 is like 6 or 10 upon 3. Well, yeah, so C is also correct. C is correct, D is correct, A is correct. One side is 5 upon 2 ml squared. So like what, 2 times of ml squared upon 2 upon 3 आने वाला है, and then plus just ml squared over there, of course. It's just plus 1, like 5/3. 5/3, not 5/2. So A, B, C. Next question. #17, which is P is the center of mass of 4 points A, B, C, D. Okay, which are coplanar but not collinear. Okay, cool. P may or may not coincide with one of the point masses. Wait, जो 4 point masses, that's like, oh god. अच्छा हाँ, मास जो है उनका अपने को पता नहीं है, so like it's a weighted mean or something, right? Okay. P may or may not coincide with one of the point masses. अगर उनका मास नॉन जीरो नहीं रहा, then that's not going to ever happen, because नहीं हो सकता है यार, हो सकता है, शायद से हो सकता है. Wait, not collinear you are saying? Shit. नहीं, still हो सकता है. For example, ये assembly देखो ना, it can happen कि वो एक पे coincide कर डाले. So yes, these, so P may or may not coincide with other pointers. So A is correct for sure. हो भी सकता है, नहीं हो सकता है, डिपेंड. P must lie within the quadrilateral ABCD. अबे ये कहाँ पे quadrilateral है? ये है क्या quadrilateral? कुछ भी. This is no quadrilateral, so uh, फिर okay like this. God. Um, must lie inside the quadrilateral. Listen, I believe that's not the case. It does it have to be like that? He must lie. शायद से नहीं भी हो. Who knows, right? So what if like it's this? So ऐसा है, right? So these are our points. This is a quadrilateral, I know, अजीब है. And what will say is कि इसका मास बहुत छोटा है, इन दोनों के मास बहुत बड़े, इसका मास बहुत छोटा है. So then actually center of mass यहाँ पर है, almost. Quadrilateral में नहीं है in that case. So no, it's not necessarily inside the quadrilateral. Okay, so B is wrong. B must lie within or on the edge of at least one of the triangles formed by A, B, C, and D, 3 at a time. Okay. Very weird. One of the triangles, शायद से, I don't know what that. He must lie on a line joining two of the points A, B, C, D. No. Q. D तो कुछ भी है. So either C is correct or not, I don't know. Must lie within the edge, or on the edge, or at least one of the triangles formed by the A, B, C, D, 3 at a time. It was scaling this up or something, right? Yeah. Think. Okay. I have no idea इसमें कैसे approach करूँगा. So मैं think you can't like approach it normally. Yeah. Must lie on one of these. Oh, I don't know. Move on, next question. But और कोई तरीका है नहीं. You'll have to do it in some ways. Let's just say ABC is a triangle. Acute, obtuse, we don't know. If it's a triangle, then like जो P रहेगा, does it necessarily lie inside the triangle? I have no idea. Think about it. Does it necessarily lie inside a triangle? Right, triangle की बात कर रहे हैं. I think it does, right? Yeah, it has to. Okay, think. Does it lie? Point. हमारे मास नेगेटिव तो हो नहीं सकते, so that's not good. It's like A plus I don't know, like B times of B plus C times of C upon 1 plus B plus C, right? something of this sort. So with respect to A, वो कैसी position है इसकी, right? Yeah, we can think about that. So with respect to A, just say like it's B dash, जहाँ पे B dash is the vector of, yeah, it's B minus A of course. And C dash, yeah, then upon 1 plus B plus C. The weird thing is कि यहाँ पे 1 plus E plus C आ रहा है, not what I thought this would be. Okay, this is the thing. Cool. So it's like this thing B dash upon 1 plus E plus C. Sorry, it's B. Okay, that's for B dash plus, right? Okay, cool. ये दो ऐसे वेक्टर्स हैं इनकी बात कर रहे हैं अपन. ओके, और ये जो क्वांटिटीज है इनकी एक प्रॉपर्टी दैट एक्स, लेट्स जस्ट कॉल दिस लाइक एक्स एंड वाई. सो एक्स प्लस वाई इज लेस देन 1 फॉर श्योर और इक्वल टू, इफ दैट हैपेंस, सो इट्स लेस देन और इक्वल टू 1. दैट्स व्हाट वी आर सेइंग, राइट? सो एक्स और वाई ऐसे दो, राइट, इट्स लाइक लेस देन और इक्वल टू 1. इसका जो पोजीशन, राइट, ओके, देन इट्स लाइक नेसेसरली inside of that or something. Okay, think. I mean, for sure, it's like some kind of average of these vectors. I get that. But you can do this thing, I guess. So it's like x b vector, sorry, b hat, जो भी है, plus y c dash. अपन इसकी बात कर रहे हैं, where x and y are such that this happens, right? You can always do it like this thing, x plus y, and then this times of x plus y. So कोई तो भी चीज जो कि 1 से छोटी है times this thing. Now isn't that like something that lies on this line, right? और फिर उसको तुम scale down कर रहे हो towards A, which basically proves कि तुम तीन पॉइंट्स की बात करते हो, तो तुम्हारा जो center of mass that lies inside the triangle all the time. अब एक चौथा पॉइंट इसमें तुम डाल दो, it must lie on one of these regions. बस में ये वाला ट्राइंगल है, I don't know, ऑब्ट्यूज होगा, कुछ भी होगा, अपने को फर्क नहीं पड़ रहा, राइट? कैसा भी होगा ट्राइंगल, we don't care about this. तुम्हारे पास में इतने रीजन, तो इसको एक ना एक रीजन में इट मस्ट लाई. सपोज वो इस रीजन में है, देन ऑफ कोर्स तुम्हारा सेंटर ऑफ मास है दैट, राइट, लाइक बस तुम विद रिस्पेक्ट टू ए एक और ये चीज ऐड करते रहो. सो इट कैन आइदर लाई ऑन दिस, और अगर ऐसा नहीं होता देन इट हैज टू बी लाइक पुल्ड टुवर्ड्स दिस गाय, राइट? या इट्स लाइक इट्स बीइंग पुल्ड टुवर्ड्स दैट गाय, दैट्स व्हाट आई विल कॉल इट. और इसका मतलब हुआ कि इट्स somewhere over here, इस लाइन पे कहीं भी रहेगा, राइट? सो ये सेंट्रॉइड जो है, इट्स गेटिंग वियर्ड, isn't it? Yeah, this is getting weird. Another linear combination, god. With a point inside of that, then तुम इसमें एक और d add करना है, so that, yeah. तुमने सपोज वो पॉइंट मतलब क्रिएट कर दिया कोई तो कॉम्बिनेशन करके, और फिर तुम एक और कॉम्बिनेशन करोगे टू क्रिएट बेसिकली सेकंड पॉइंट. तो तुम ये जो डी ऐड कर रहे हो, वेटिंग दिस, तुम जब वेट करोगे तो फिर एक्चुअल में इसके बीच में इस लाइन में कहीं भी आएगा, राइट? अब नाउ थिंक अबाउट इट एज डी मूव्स, राइट? एज डी मूव्स हमारा क्या हो रहा है? अगर ये इस रीजन में है डी, देन it has to be confined to this triangle, right? Because like as d moves, you know the thing, right? ये इस line पे रहने वाला है, so it will be either inside this triangle. अगर नहीं है then it's like sucked up to this point, और वहां पे तो वो ऐसा हो गया. Okay, तो ये इस रीजन की बात है, और सिमिलरली ये दो रीजन की बात कर रहे हैं. अगर d यहाँ पर है then what? Then once again you can make these two triangles, और फिर once again same thing कि you know कहीं तो भी यहाँ पे रहने वाला है. इट कैन बी आइदर इन दिस ट्राइंगल और दिस ट्राइंगल, इस रीजन में रहेगा बेसिकली. दैट्स द थिंग, राइट? सो दैट्स इट, वी जस्ट प्रूव दैट इट हैज टू बी द थिंग. सो सी इज इन फैक्ट करेक्ट. सो सी इज अ करेक्ट थिंग. यार मुझे ये ऐसा प्रूव करना तो था नहीं, मैंने क्यों किया ये सब? फाइन, देन 17 का सी भी करेक्ट है. 18 is when slightly different weights are placed on the two pans of a beam balance. The beam comes to rest at an angle with the horizontal. Beam balance, okay, slightly different weights are placed on it. The beam comes to rest at an angle with the horizontal. No, I don't think that's what happens. But torque जो रहेगा बीम पे वो still same है, so नहीं, ऐसा नहीं होता है, right? My torque को zero नहीं हुआ अभी भी. Yeah, right. Torque is still not zero, so no, that can't happen. अनलेस तुम्हारा टॉर्क, तुम्हारा जो बीम है वो फेल. दिस इज नॉट आइडियल कंडीशंस. दैट्स व्हाट्स हैपनिंग आई थिंक, राइट. Beam comes to rest at an angle with the horizontal. Wait, what is a beam balance? ये नॉर्मल का जो तराजू है वैसा नहीं है. लाइक नॉर्मल क्या रहता है कि तुम्हारे उसमें एक रॉड है, उसको तुमने बीच में से हिंज किया और यहाँ से तुमने वेट्स हैंग किए, राइट. और फिर जो भी बड़ा होगा उस साइड में गिर जाएगा, राइट. दैट्स व्हाट हैपेंस. देन व्हाट्स अ बीम बैलेंस? ये बीम बैलेंस नहीं है कि. वेट व्हाट? अच्छा, बीम इज सपोर्टेड बाय सिंगल पिवट पॉइंट P. ओके, then it's like this, of course. It's this, yeah. Let's talk about P. Do the two weights is non-zero at the equilibrium position. Yes, that is the thing. What could be going off? I don't get it. The whole system does not continue to rotate about P because it has large amount of inertia. That is stupid. The center of mass of system lies below P. What? Beam का mass होगा ना फिर. Probably right. The only thing that could be, नहीं, अगर बीम का मास देन ऑलरेडी इट इज फॉल्ट. सो ये तो ऐसा नहीं हो सकता. आई एम अज्यूमिंग कि आइडियल बीम बैलेंस है. देन नो, दिस विल एक्चुअली नेवर हैपन. सेंटर ऑफ मास रेस्ट एन एंगल तो हो सकता. आई डोंट गेट इट. दिस कैन नेवर हैपन. तो फिर ये कैसे? Slightly different weights and it still comes to balance. Oh, there's only one way. अगर ये massless है, which is it should be, it's an ideal condition, then ये जो pivot point है, it should be over here. That explains a lot. Okay, so it's actually not at the center. Okay, did not talk about P due to the two weights is non-zero. No, it is zero. Okay, the whole system does not continue to rotate about P because it has large. No, that's stupid. Center of mass of system lies below P. What? It lies below P. Like, ठीक है ना, like, so this is x and this is y. So let's say it's m1 m2. So फिर x m1 is equal to y m2, of course. पर इसका मतलब है कि अपन सेंटर ऑफ मास कैलकुलेट करेंगे तो वो तो P पे आ जाएगा, राइट. या राइट, डेफिनेटली. और उसका अपन थोड़ा सा राइट, एक्चुअली P पे नहीं है, उसके यहाँ पे ये स्ट्रिंग्स भी है, सो यू हैव टू टेक दोस इनटू अकाउंट एज वेल. सो यस, इट डज लाई बिलो P. ओके, वेट, व्हाट अबाउट P? व्हाट डू यू मीन? कम ऑन, ये क्या है यार? इट डिपेंड्स. तुमने ऐसा रखा है कि तुमने यहाँ पे ऐसे बाउल्स रखे हुए. कम ऑन, व्हाट इज दिस? टू पैन्स ऑफ अ बीम बैलेंस. लाइक पैन्स ऐसे है क्या? यार ये बहुत वेग डिस्क्रिप्शन नहीं दिया इन लोगों ने. मतलब दोनों भी सी और डी करेक्ट हो सकते हैं गिवन प्रॉपर कंडीशंस, राइट. एनीवे, आई एम गोना से सी एंड डी. आई हैव नो आइडिया बिकॉज ए एंड बी तो करेक्ट नहीं है. नेट टॉर्क जीरो तो होगा ही, वी नो दैट. The weights is non-zero. No, that is zero. The whole system does not continue to rotate about P because it has large amount of inertia. That is stupid because even though inertia B बड़ा हो सकता है, वो still rotate करेगा because like come on, we know what happens, right? थोड़ा बहुत rotate तो करेगा ही नहीं, कितना भी तुम large पर डालो. Okay. Yeah, then C and D are the only correct options. और ये multiple choices मैंने से किया. Most likely C और D होना चाहिए because it depends कि pan की position क्या है. But like whatever. 19th. मोस्ट लाइकली बिलो रहेगा यार. अबाउट क्यू होगा. ठीक है, फिर इसको से सी इन दैट केस. 19th. Block with a square base measuring a to a and height h is placed on an inclined plane. The coefficient of friction is mu. Okay, the angle if inclination of the plane is gradually increased. Okay, angle of inclination. Okay, the block will राइट. ये वाली चीज है ना. ओके, कूल. सो टॉपलिंग की कंडीशन क्या रहने वाली है इसमें? इसका मास कहाँ पर ऐसा. ओके, इट्स लाइक every side and this direction and education and dimension or whatever. तो टॉर्क आने वाला है अबाउट दिस पॉइंट आई बिलीव, नॉर्मल भी है ना इसमें, और या normal vector that we have dot. God, I don't like that. Normal vector. Oh, हाँ, अगर टॉपल करना है then normal vector is acting at this point itself. That's the limiting condition. That means like okay, that is the thing. So exactly इसके ऊपर आ जाएगा, right? So what is our thing like mg sine theta times h upon 2 in this direction, that has to be equal to, it's like that, just yeah, cosine theta and then a upon 2. So basically this happens. So tan theta is equal to a upon h, right? So जब ये topple करता है then this should happen, and if it slides then what should happen is that tan theta is equal to mu. Okay, so अगर mu बड़ा है tan, so initially like was 0, okay, it's like increasing. So topples before sliding if mu is bigger than a upon h, well yeah, I believe that. Slides before toppling if mu is less than a upon h, not okay. So A is correct and D is correct, I think. Next question. 20. 20 is a man spinning in free space changes the shape of his body. Okay. Okay. By doing this, he can change moment of inertia. Yes. Angular velocity. Yes. Angular momentum. No. Kinetic energy. Yes, he can actually. अपन ने एक बार किया भी था इनफैक्ट, वो खुद ही वर्क कर रहा है खुद पे बेसिकली, बिकॉज टू पुल हिज, तुम्हें पता है क्या है, राइट? वो वॉच दैट वीडियो, जब एकदम नया नया था मैं, तब मैंने वो वीडियो क्रिएट किया था, दैट इट डज चेंज. वैसे भी अपने को पता है लाइक हाफ आई ओमेगा स्क्वायर, वो दैट डज चेंज, राइट? ओके, सो डी इज करेक्ट, ए इज करेक्ट, सी इज करेक्ट, ए सी डी. कैन नॉट चेंज तो नहीं था ना, कैन चेंज ऑफ कोर्स. दैट्स इट. ओके, 20 क्वेश्चंस डन. आई गेस वी शुड स्टॉप फॉर नाउ. So I'll see you guys in the next video.